Hello everyone, this is J. Manasabindu from EC department. Now pursuing BTech first year, first semester, graduating Srinivasa Ramanujan Institute of Technology. Now explain about parallel circuit. The circuit consists of R1 and R2 resistors in parallel. The current flowing R1 and R2 are I1 and I2. We can see the diagram R1, R2, I1, I2. I means current, R is resistor, V is voltage. Plus ante positive. We can see R1 and R2 resistors. The current flowing is R1 and R2 resistor. We can see equation R is equals to R1 by R2, R1 plus R2. The total equivalent resistance is given by 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on by 1 by R1. Components of parallel circuit. Parallel circuit subtopics are there. Power source. The electrical energy such as a battery or power supply. For example, the electrical energy as a battery or power supply. You can see battery or power supply, you know that. Loads of components. Device or elements like resistors, bulbs or any other electrical components that consume or control the flow of current. Nodes. Point where the components are connected to each other and the other power source. Wiring. The connect the components to the allow of flow of electrons. We can see connecting wire or components and allow the flow of electrons and the flow of current. Voltage in parallel circuit. The voltage across each component or branch in a parallel circuit is the same. This is a fundamental characters of parallel circuit where all components share as the same voltage across their terminals. Unlike series circuits where voltage add up in parallel circuit, the voltage is consistent across all branches, making it a key feature of their behavior. We can observe that unlike series circuits where voltage add up in parallel circuit, the voltage is consistent across all branches, making a key feature. Current in parallel circuit. Total current. The total current flowing from the voltage source into the parallel circuit. It is the sum of the current flowing through each branch. Branch means current flow, the flow of electrons. The individual current is flowing through each parallel branch. The current through each branch is determined by Ohm's law. 1 by V by R, where V is the voltage across the branch and resistance of the branch. These two types of currents are interconnected and the total current is algebraic sum of branch currents due to the conversion in a parallel circuit. We know the current through each branch is determined by Ohm's law by using a Ohm's law, where V is voltage across the branch or is the resistance of the branch. Resistance in parallel circuit. Equivalent resistance. The overall resistance of the entire parallel circuit as seen from the perspective of the voltage source. Branch resistance. The resistance of each individual branch or component in the parallel circuit. These resistors are connected in parallel with each other and the reciprocal relationship affect the overall equivalent resistance. Understanding these resistance type is crucial for analyzing and solving problems in parallel circuit. Power in parallel circuit. In a parallel circuit, the voltage across each component is the same. We know parallel circuit, the voltage is the same component in every. While the current varies, the total power in a parallel circuit, the sum of power consumed by each individual component. The power can be calculated by using formula P is equals to V by I, where P is power, V is voltage, I is current. We know that P is equals to V by I. Advantages of parallel circuit. Components in a parallel circuit operate independently, so if one component fails, it doesn't affect the others. Voltage across each component remains constant, providing stable power to individual devices. It's easy to add or remove components without affecting the rest of the circuit. Parallel circuit enhance system reliability as the failure of one component does not disturb the entire circuit. We know parallel circuit enhance system reliability as the failure of one component is wrong, the circuit is a component does not disrupt of the entire circuit. Applications of parallel circuit. Residential electrical wiring often employs parallel circuit. Each electrical outlet and appliance operates independently, ensuring uninterrupted power in if one device fails. Parallel circuits are used in lighting installation, allowing each light bulb to operate independently. If one bulb burns out, the other remains it. Parallel configurations are used in battery packs to increase overall capacity. Each battery operates independently, contributing to the total power output. We know that residential electric wiring in parallel circuit, ensuring the uninterrupted power if one device fails. We know circuit diagram components are connected are there. Is one circuit is fails, not operated there. Thank you.